Map, IP, DLC broadcast, map, IP, DLC broadcast, map, IP, DLC broadcast, map, IP, DLC broadcast. What's up? It's your boy, The Network. And today's topic is not about Migos and Bad and Bougie. It's about frame relay. This is subsection 2.2A alpha, frame relay operations. This is a subsection of section 2.2, explain frame relay, which is part of the CCNP route exam code 300-101, version 2.0. Let's look at the exam topics, the exam blueprint, to see where we came from and where we are going. Exam code 300-101. We just wrapped up 2.1B PPPoE, client side only, and we are now moving on to section 2.2, explain frame relay. We're going to be doing 2.2A alpha today, frame relay operations. I'm going to load up packet tracer. Yes, packet tracer for CCNP route exam, because I just wanted to show y'all the basics of it. You can go a little further by putting some debugging commands and looking at the actual LMI messages going back and forth and stuff like that. But I'm not going to do all that. I'm just going to do some basic configuring. After that, we're going to do point-to-point in the next video. Point-to-point frame relay. For now, we're doing frame relay operations. So frame relay is, I'm actually surprised, is on the CCNP route exam, being that for IC and D, actually the CCNA exam, they actually took out frame relay, and they haven't updated CCNP route yet, so that's probably why they still have frame relay on this. It's basically a layer 2 wide area network solution. So, you know, normally you use IP, which is layer 3 on the wide area network, but frame relay is a way to use a layer 2 solution on the wide area network. So you are encapsulating all your data in frame relay packets, frame relay Ethernet packets, which go across the network using frame relay switches. But with instead of frame relay switches, we use routers as frame relay switches. And I'll show y'all how to do that on packet tracer. Moving right along. These are the commands we're going to go over. A show command, that's the only one I believe that's supported on packet tracer. Show frame relay map, and the actual configuration to map a what's called DLC. We'll go over what that is, to an IP address. That's why I did that little corny way to remember the command map. You do frame relay and then map, and then IP, and then the IP address that you want to map it to, the DLC you want to map it to, or DLCI, and then you got to put the keyword broadcast. This is the official definition got from Cisco. Yes, I ain't really like it, but we're gonna go with it anyway. It's an industry standard or protocol, switched data link layer protocol that handles multiple virtual circuits, including HDLC encapsulation between connected devices. Frame relay is more efficient than X25. So frame relay was the replacement for X25. That was the old protocol, the protocol for which it generally is considered a replacement, just like I said. So this is a basic topology of frame relay network. You have your device would be considered the DTE. We'll go over the terminology later. I believe that's data terminating equipment. So you see all these routers on the right, on the outside, that would be your device, the data terminal equipment, which sits on the customer premises side. And you communicate with the service provider, which is there in the cloud. They have the frame relay switches, or it could be a router acting as a frame relay switch. Those are known as the DCE. They are the ones that provide the clocking protocol, the speeds, etc. Those are considered the data circuit terminated equipment. Again, that's typically owned by the service provider. Let's go over some more of the terminology here. Again, DTE, data terminal equipment, that's what you own on your side of the DMARC. They accept the parameters such as clock speed, etc. Then there's DCE, like I mentioned, That's the one that the service provider owns. They're the ones that provide those parameters. See over here on the inside, that's the DCE, right? They're the one. That's the ones that the service provider own. That's why it's in the cloud. They communicate with what's called SVCs and PVCs, right? So if you notice here, there's no direct connection between these devices. That's the thing with, I forgot to explain this. So with frame relay devices, you could have, let's say, an office in, let's say you got your office in New York, and you have a remote office in, say, Phoenix, Arizona. Now, you could have a line going from New York to Phoenix, Arizona. Obviously, it's going to be too expensive to have one long-ass cable going from New York to Arizona, right? So you got to get a lease line. You got to use, cables that's owned by other companies. That's called a lease line, right? Now, you could just use all those cables and get all the way to Phoenix, Arizona, right? That's going to be costly if you just have one dedicated leased line to your New York office to Arizona, right? That would be the solution if you just have just one office, right? But let's say you got one office in New York, but you also got an office in Atlanta, Georgia, the Phoenix, Arizona one, and you also got one in LA. So now you got 3 offices that you need to connect to, right? Instead of having a dedicated lease line for each one of them, that's going to be too costly because you might not use all the bandwidth all the time. So what you do is you would share the bandwidth by using a frame relay connection, otherwise known as a PVC, a permanent virtual circuit. So you would be sharing these lines, these PVCs, with other companies instead of having one dedicated lease line to yourself. So I'll show you an example in this other picture right here, which looks a little, okay, so let's say this is your headquarters, right? On the left-hand side, that's your New York office, right? And then you have these 2 branch offices. Let's say one of them is the Phoenix, Arizona one, and you got your Atlanta, Georgia one right here. You have what's called these permanent virtual circuits, that's here on the red, that allows you, because you don't have a direct line to these offices. You just using a frame relay switch to get to them. And you use what's called DLCs, right here on the, you see where it says DLCI 102? You map that to an IP address, which say you have the IP address for your Phoenix office. And that's how you have the connection from headquarters to branch 1 or Phoenix, Arizona and LA. That's your permanent virtual circuit. You would have a switched virtual circuit. That's a temporary connection that's brought up when data needs to be sent. Only when data, kind of like a DMVPN connection. So let's say you have an office that's, you don't even have an office. You just have like a virtual, like a remote worker somewhere, and he just out in, an office somewhere else, like, I don't know, Michigan or something. And you just bring it up. He only sends information, like he only sends data a certain amount at a time. So you'd have a switched virtual circuit to that location. But normally service providers, they usually sell PVCs, a permanent virtual circuit. And again, DLCI, also known as DLCs, that's a 10-bit value that acts as a layer 2 address that's mapped to the IP address. That's how you know. So if you look at this connection, this right here, you got branch 1's office, you have their serial interface, right? But using you don't have a dedicated line to them, so you're not going to know their serial interface. So what you're going to do is you're going to map it to what's called a DLC. That number is only locally known to this router, but you map it to that serial interface IP address, and that's how it knows how to connect to it, by using that permanent virtual circuit. So DLC 10, that DLC 102, any traffic that needs to go to that address needs to go to DLC 102. On the flip side, when he needs to send information to that serial interface, he's going to map DLC 201 to that IP address. And that's going to be the permanent virtual circuit for that. Same thing with this side. 102 or 103 is going to be mapped to that IP address. And 301 is going to be mapped to this IP address. I'll show y'all an example of that in Packet Tracer. A little bit more definition. I ain't even finished these slides. I ain't want to throw too much definition at y'all. If y'all want to do some more, I may just put the links in the description. Honestly, like I said, frame relay is old technology. I'm surprised it's still on this exam. It gets a little confusing, this old technology, but it's still used today. We're gonna go over it anyway. I'm gonna put some more definitions at the bottom of the description here. Let's see. So we got 3 standards, 3 LMI types, also known as. We got Cisco, which, so when you have these devices, the standards got to be the same for them to work. If you got one Cisco device and you got a non, like say, I don't know, Juniper or something, they have to use something that's an industry standard protocol. You can't use Cisco between the 2 devices as the LMI type. So you got to use either ANSI or Q.933 That's going to allow you to, like, if you got a Cisco device and a non-Cisco device, you have to use ANSI or Q.933 If you have both Cisco devices, you can use Cisco as the LMI type, and they'll be able to communicate over a frame relay network. But those have to be, those have to match. I ain't even, like I said, I ain't finished these PowerPoints. I had a lot going on. I will put the definitions and what these standards are below in the description. Let's see what we got going on here. So yeah, again, LMI, that's the set of enhancements to frame relay. They also send status messages. So it tests the link between that PVC. So the LMI tests the link and it reports the status and the health on the PVC connection. That's what the LMI messages do. You know, if you could do, you can do a debug frame relay, I believe map, and you should be able to see the status of the PVC connection. Okay, here goes some more frame relay terminology. We got these bits. I don't even want to go over this, but let's go over it anyway. So these are the frame relay congestion avoidance. This is like a congestion avoidance mechanism. Basically, the first. So this is what a frame relay header looks like right here at the bottom, right? Now the FCEN bit, if the network is congested, it's going to let the destination device know that the path it took was congested. It's going to set this to 1. And then the BECN bit, which is the second one right here, that sets the bit to 1, letting the initial sender know that the path is congested. So when, let's say headquarters sends a message to branch router 1, right? And it gets there, right? But the path it took was congested. When it sends that information back, BECN is going to be set to 1. That's going to let the headquarters know, okay, that path is congested. We may have to take another path or find a better way to get there, even though that's really the only way to get there, but it'll let it know that it's congested. Now, the last bit is set to 1. When this DE bit, discard eligibility, if it comes in, it's going to just drop the frame. It's just going to be like, oh, I don't need this because that network was just too congested. It's going to drop the frame if the DE is set to 1. This is the frame relay terminology or frame relay topology with the DELCs and the IP addresses. So basically, you mapping the DELC to the IP address, and that's how it knows how to get there. But remember, these numbers, these DELCs are locally known to the router. So branch router 1 doesn't know about DELC 102. He just knows that 201, because this is locally known to him, is mapped to that IP address because that's something that's manually done. Now, the LMI by default is set. The LMI is set to auto sense, so it just knows the encapsulation type, the LMI type, these types, but it don't know the frame relay. That has to be done. That has to be done manually. Let's go ahead and launch Packet Tracer and configure a basic frame relay. Okay, so this is a, let's go ahead and reset this. Configuring static frame relay maps. Just a basic setup. Now, if you want to get a little bit more hands-on with this, it's best to use GNS3 and build a network from scratch. I like to do this so that way it's easier for me to explain as I'm doing it along with y'all. All right, part 1, configure frame relay. In this activity, we're going to configure 2 static frame relay maps. Although the LMI type is auto-sensed on the routers, just like we said, you will statically assign the type by manually configuring the LMI. Okay, we're going to configure frame relay. Configure frame relay encapsulation on the serial 000 interface of router 1. Let's bring up router 1. That's another reason why I like Packet Tracer. I love looking at the routers here, even though I got some hands-on devices that I could use, but I just like seeing the devices and stuff. Kind of helps to know what they look like. This is a 1941. We're gonna go enable mode, configure terminal. Let me make this a little bigger so y'all can see. Configure terminal, interface serial 000. We're going encapsulation frame relay. We have 7% of this complete, right? So it says here we have to do the same thing. Configure frame relay encapsulation on serial 000 interface of router 2 and 3. So we're just going to do the same thing of routers 2 and 3, right? Also notice we have a PC here, a laptop here, and a web server here on the local area networks. The internet is located right here. You can go ahead and zoom in for y'all can see too. So we're going to do the same thing on router 2. Enable, configure terminal. Encapsulation, interface serial 000, encapsulation frame relay. Okay, so we got to do the same thing to router 3. Enable, configure terminal, encapsulation, interface serial 000, encapsulation frame relay. All right, so we got the encapsulation. Let me show y'all, just so y'all know. These are the 3 types, right? Do you remember what the default is? Pop quiz. HDLC. Y'all remember in HDLC from the, I believe the PPPoE, or the PPP video. Encapsulation by default is HDLC. After that, we went over PPP. And then now we're doing frame relay. So these are the 3 layer 2 solutions that you could use on the WAN on the WAN scale. So today we do frame relay. All right, so we gonna test connectivity. So we gonna from the command prompt on the PC, go to the PC, verify connectivity to the laptop. The laptop's IP address is 192.168.30.10 using the ping command. It should fail because router 1 does not have a route to reach the 168.30.0 network. Router 1 must be configured with a frame relay map so that we can find the next hop destination to reach that network. Let's go ahead and try it. I already told y'all what the result is going to be, but let's do it anyway. 192.168.30.10. Destination host unreachable. Unreachable, timed out, and it didn't make it. 100% loss. Again, why? Because it doesn't know how to get to router 2. So the way we do that is we got to configure a static map in LMI types, and that should allow us to connect to router 2. But we don't have to do the same thing to router 3. We're going to have to create a map for 3 and a map for router 2. And there's also has to be a map going back too, so that's way it knows how to get back. You will have a way to get there, but you need a way to get back too. Configure static map on router 2 and router 3. Configure router 1 to use static frame relay maps. Use DLC 102 to communicate from router 1 to router 2. Then use DLC 103 to communicate from router 1 to router 3. So let's go ahead and do router 2 to router 1 to router 2, right? Nope, not the PC. We'll go to router. Exit out of that. Actually, that's where we was at. Interface serial 000. Frame relay. And this is where that song came in. Map, IP, not the IP, but you put the IP address there. 10.1.1.2. And then you put the DLC, which is 102. Then you got to put this keyword broadcast. Let me show y'all what that means. Broadcast should be forwarded to this address. That's what you're saying when you do that. If you do Cisco, it's going to use Cisco encapsulation. And these are Cisco devices, so it should work. I want to be able to test it, but I ain't do that yet. But anyways, we using broadcast because the ERGRP is set up on these, so you need multicast. That's why you've got broadcast on here as the keyword you have to use. So let me show y'all. See, broadcast should be forwarded to that address. That's what you're doing here. So again, broadcast. Now we've mapped it. And we have to do the same thing for router 3. Now we got to create a map to router 3. We created a map for router 2. Now we create a map for router 3. The way we do that, frame relay, map, IP, which is the address, 10.113.102, or 103 is the map the DLC you want to map it to, broadcast keyword. Notice how we're at 41% of this complete. So now we've got a way to get to router 3 and a way to get to router 2. Is that going to work? Can we ping these devices now? Let's go ahead and try to ping the. We know the web server was going to fail because they weren't going to work at the beginning. So let's ping the web server. 209.165.200.2. So we're going to ping this guy. This guy is going to ping that guy. Let's go ahead and try that. Ping web server 165.200.2. Is that going to work? Destination host unreachable. Who does that come from? 168.10.1. That is our gateway. That's our GI00 interface. This guy right here told us unreachable. Remember the unreachables video, right? If you don't, look in my CCNP route playlist, you'll see a video called ICMP unreachables. So we got an unreachable here. Let's try the laptop again. Laptop was 30.10, right? That's this guy. Destination host unreachable. Even though we created a map to these routers to get to those locations, we don't have a way to get back. That's why they are unreachable. So next step is we're going to have to configure router 2 to create use static frame relay maps. So let's go ahead and create a frame relay map from router 2 on back. Is it still going to work if we got to route back though? That's the dying question. That's what we dying to answer. Okay, so we're going to use DLC 201 to communicate from router 2 to router 1, right? So we're going to exit out of this. Frame relay. No, we got to go back to the interface. Serial 000. Frame relay map. And then the IP address to the other location, right? So router 1. I'm sorry. The serial triple interface. So 10.111. We're going to use the DLC 201 to that. We're going to map the 10.111 address to DLC 201. So the IP address, IP, DLC 201 broadcast. Notice how we're at 51% complete now. Now we got to create a map from router 2 to router 3. Let's go ahead and do that. Frame relay map IP. And the IP address is 10. What's his IP address? Router 3. 10.113. 113. We're going to map it to what? Use DLC 203 to communicate from router 2 to router 3. So 203 is the DLC. Broadcast. Notice we're at 61% of this complete. All right. So do you think we can ping from the PC to the laptop now? Let's try. Laptop is 192.168.30.10, right? Let's verify that. Yes. Ping. Unreachable. Know why? Y'all know why? The LMIs that we haven't that we discussed earlier. We haven't declared the LMI type to this serial interface. But before we do that, let's go ahead and create a map from router 2 to router 3. We did the same, I'm sorry, from router 3 to router 1 and router 3 to router 2. So we're going to create static maps for these guys from router 3. We created from router 2 to router 3 and router 2 to router 1 and router 1 to router 3 and router 1 to router 2. But now we got to create maps going the other way around. I know this it's a little consuming, time consuming, but that's just the way it is. This is all stuff that you got to statically configure. All right, so we already did the encapsulation frame relay, right? So now we got to create the maps, right? Frame relay map IP address for router 1, which is 10.111, and then the DELC we need to map it to is use 301, right? So use DELC 301 to communicate from router 3 to router 3. Can't move that, can I? Router 3 to router 1. Let's go ahead and do that. IP address 10.111. The DELC is 301. Broadcast. Notice how we're at 71% complete. We're almost done here, y'all. Bear with me. So now we got to create a map from router 3 to router 2. Right? From router 3 to router 2. Let's go ahead and do that. Frame relay map IP 10.1.1. What's his address? I believe it's 2. They did the the numbering scheme, the IP addressing scheme correctly here. Well, not correctly, but one that makes sense. And that's what you want to do when you create these topologies. Use the IP address that's going to make sense to you. See, notice how router 2 ends in a .2 address. 2. And then the DELC, they did the same thing with the DELCs on this. Use DELC 302 to communicate from router 3 to router 2. So 302, my bad, 302, broadcast keyword. And we almost done here, y'all. We got 81% of this complete. So now we've got maps to all of these guys going there and back. Do you think it's going to work? Can we ping the web server right now? What's the web server's IP address? Web server is 209.165.200.2. You think it's going to work? Let's see. Destination host unreachable. Who told us that? Who told us that? Router 1 did. Router 1 said, nah, man, it's unreachable. I don't know how to get there. It could be that the device is down. Actually, yeah, it could be that the router is down. So you would get an unreachable and like that as well. So yeah, basically we have to configure ANSI as the LMI type. I'm gonna put a link in the description on the LMI types below. So let's go ahead and router 1. On the same interface, we have to do frame relay LMI type. And these are the types of LMIs like I mentioned before. ANSI, which is vendor neutral. Cisco, which is for Cisco to Cisco devices. It might work. We'll try it and see if it works. And then the same thing with Q.933 A. It's not Cisco devices. It's vendor neutral. This is a vendor neutral open standard basically. So LMI type ANSI. That's right. It ain't. So now notice how the serial interface is up. It was down before. Let's go ahead and do a show IP interface brief. And now serial is up, right? We haven't configured the LMI type on router 3 yet. Let's go ahead and see what his status is. I believe you can see it's down, but let's see. Do show IP interface brief. Serial interface is actually up down. Let's go ahead and configure the frame relay type on that serial interface. And remember, we have EIGRP set up on these bad boys too. So that's why these routers are not directly attached, right? So that's why EIGRP is not going to work. We have a frame relay cloud in between these guys. So we need to statically map the IP addresses, and then you should be able to see it come up. Interface serial 000. Frame relay LMI type ANSI, and wait for it. Notice how the serial interface is up, changed from up down to up, and we also have an EIGRP adjacency now. So even though these guys are miles away and they've got something in between them, they got the cloud, the frame relay cloud between them, we are using, that's what the broadcast keyword is for EIGRP to work. So now we've got can we ping the web server now? Most likely we can. So we're going to use the PC and try to ping the web server. So we're going from router 1, router 3 to the web server. Let's go ahead and do that. Pinging, timed out, and now we got a reply. We're 94% complete, so we just need to, can we ping the laptop now? Let's go ahead and see if we can ping the laptop. What was the laptop's IP address? 192.168.30.10. That's this guy. Can we ping him? Pinging. Timed out. I'm going to tell y'all right now, it's not going to work because we need to configure the LMI type. Even though it's auto sensing, we still have to configure the LMI type to ANSI. Let's go ahead and do that. Configure, actually exit, frame relay, LMI type, ANSI. Notice how we're 100% complete. And now we've got an adjacency and our serial interface is up. Serial interface is up. EIGRP. We've created an adjacency with router 3 and router 1. We've got EIGRP adjacencies. Let's go ahead and see if we can ping the laptop now. It's 30.10, right? Pinging. Timed out, and now we got a reply. It looks like we're good to go now. So that's how you basically configure a basic frame relay setup. After this, we gonna go over point-to-point setup for frame relay. For now, go ahead and comment, like, subscribe to the network.